When I was younger, I always wondered why Earth felt steady, unlike the thin, freezing air of Mars or the toxic heat of Venus. As I learned, it wasn't just luck. The sun burns slowly enough. The orbit stays smooth. The air stays thick yet breathable. Layer by layer, every system seems tuned to keep things steady. And yet, ask any scientist and they'll tell you, habitability hangs by the thinnest thread. So how do we make sense of a stack of coincidences this precise? Let us begin tonight's journey by imagining a night sky with no moon. The stars are still there, scattered and sharp, but something about the view feels strangely flat. The sky is darker, more haunting, and there is no soft silver light to pull the oceans back and forth, or to mark out the steady rhythms that we rarely notice but deeply depend on. It is a sky that looks familiar, but somehow empty, as though the world beneath it has been robbed of a quiet companion that does more for us than we often admit. When we look up at the moon today, we might see it as decoration, but in practice it is nothing of the sort. Its pull, subtle but persistent, tugs on the seas, lifting water into tides that move in and out as if the planet is breathing. Those tides keep the coastlines alive, stirring nutrients, feeding fisheries and shaping ecosystems. The moon's gravity also acts on the whole Earth, holding the tilt of the planet like a steadying hand on a spinning top. With that stability, seasons arrive in a predictable cycle, neither too violent nor too stagnant. That regularity lets life sync its patterns across generations. So let's imagine the moon taken away. The ocean still exists, but the tides are hardly recognisable. They shrink to a faint ripple, barely moving, like lungs that can no longer fill with air. Nutrient cycles falter, shorelines stagnate, and ocean life that depends on the choreography of the tides begins to break. The small creatures that use tidal pools as cradles never emerge, and the food chain thins from the bottom upward. What remains is an ocean with less rhythm, less life, and less resilience. At the same time, without the moon's anchor, Earth's tilt starts to wander. In one imagined swing, the tilt is shallow, making seasons almost indistinguishable. In another, it whips to severe angles, with continents plunged into brutal winters and scorched summers. Climates would lurch between extremes with no long-term pattern to adjust to, and ecosystems would struggle to keep pace. Forests might grow in one zone only to shrivel within a few thousand years. Deserts would spread where once grasslands thrived, and ice sheets would march and melt with no reliable cue. The predictability that most species quietly rely on disappears, and survival becomes a chaotic wager. Think of daily life as well. Our biological clocks are not random. They respond to the rhythm of days, nights, and tides. The moon's glow has guided countless reproductive cycles in ocean life. Its phases have shaped how predators hunt, and humans themselves once set their calendars and stories by its monthly track. Without it, the night becomes not just darker but slower. Animal rhythms lose a common signal, migrations and breeding seasons fragment, and a planet that once walked to a shared beat begins to stumble out of step. For evidence of what can happen to a world without a stabilizer, we only need to glance toward Mars. Its tilt drifts widely over time. With only small moons, it lacks a strong stabilizer. Those tilt swings are thought to have helped destabilize its climate, contributing to the thin, forbidding world we see today. Where Earth's moon keeps us steady, Mars lost its hold, and the record of its surface suggests a world that shifted from wet to frozen, from possibility to silence. The contrast is sharp, and it shows how fragile this kind of stability truly is. And yet the moon's own birth is not a simple story of inevitability. The leading explanation is that long ago, a collision larger than imagination smashed into the young Earth. From that impact, chunks of rock were thrown up and gathered by gravity into the body that now sits in our sky. It is a dramatic scene in the story of deep time, and the outcome appears rare. a collision of just the right size, just the right force to create a satellite large enough and close enough to act as Earth's partner. That origin itself feels improbable, like a razor-thin path cut through chaos. When you think of it through a design lens, the moon begins to look less like raw accident and more like a conspicuous alignment. A satellite that steadies the axis, pulls the tides, sparks the rhythms of life, and lights the nights spent billions of years holding Earth in balance. Whether one calls it coincidence or some deeper law at work, its presence has kept the planet from sliding into chaos time and again. Without the moon, Earth does not simply look different, it works different. It loses a hand on the top, a guide for its seasons, a timer for its pulse, and a partner that helps waters breathe. In that imagined sky with no moon, Earth would still spin and orbit, but the stage for life would be thinner, harsher, and less forgiving. The life we know might be weaker, scattered, if it could survive at all. Each of these small flows, the tilt, the tides, the rhythms, shows how dependent we are on what seems like a passive object in the sky. It is not decoration, and it is not optional. It is a stabilizer, one that took a violent beginning and turned it into a steady gift lasting across deep time. You can feel the difference between chance and stability the more you imagine removing it. A deserted shore with no tide marks, animals out of rhythm with the seasons, a climate that veers so wildly that long-term balance cannot hold. The planet might still carry life, but it would be less connected, more fragile. It would not be the Earth we know. And so, if the moon can shelter us from chaos simply by staying at our side, a question rises. What protects us from the constant, invisible assault spilling toward Earth from beyond? Because unseen around the whole planet is another shield, one that pushes back against the sun itself. And without that defense, the surface of Earth would become far less forgiving. What if Earth's magnetic field switched off tomorrow? It's not something we sense day by day, yet the field stretches far above us, wrapping the planet in an unseen shield, and if it faltered even for a short time, the surface would feel the weight of the sun in a way we're not prepared for. Take that shield away, and the story of Earth would change quickly. Radiation from the sun would pour down constantly, with no deflection, no cushion. Imagine a storm in space blowing across the upper atmosphere, and instead of bending harmlessly around the planet, it strikes directly, stripping and heating everything in its path. Most of the time, we picture the sun as warmth and light, but it also hurls streams of charged particles, travelling fast, carrying energy that is neither gentle nor forgiving. Right now, those particles hit the magnetic field and spiral harmlessly into space, or they follow invisible lines that arc toward the poles, where the energy is released as ribbons of coloured light. Auroras shimmer and dance as the visible signature of a defence most of us do not realise is active. They are not just displays of beauty, they are the faint edge of an ongoing battle in the space above. Without that protection, the glow would spread across the globe, not as beauty, but as danger. If the shield dropped, those same particles would hit our upper air layer. Over time, it would erode. Molecules held in place would break free, pushed away into space. With no protective buffer, radiation streaming down would alter chemistry, breaking apart stable bonds, burning through layers that soften sunlight into life-giving warmth. The oceans would not vanish in a day, but slowly, steadily, water molecules would also be split apart. Lighter parts carried off with the wind of space. Earth, bright with seas, would turn less stable year by year. It is a thought experiment, but one rooted in observable differences. We need only look toward Mars to see what happens when protection fails. Long ago, Mars may have had rivers streaming across its surface, perhaps shallow seas, but with a smaller body, its inner core cooled faster. When that movement stopped, so did the magnetic field. Without that shield, the solar wind began to reach the atmosphere directly, stripping it grain by grain. Mars lost its thickness, its ability to trap heat, its ability to keep water liquid on the surface. Timescales long compared to our lives but short in planetary deep time erased its once rich climate. What remains is a thin veil of air and water locked as ice or clutched underground. Mars shows us the path of a world without a magnetic defence, and it is not a path toward growth. The reason Earth still resists that path lies thousands of kilometres under our feet. Deep inside is a core, the outer section molten, constantly turning. That motion, in the presence of iron and nickel, creates a dynamo, like a natural engine generating current. The flows are not neat. They are turbulent and shifting, sometimes reversing, sending the lines of the field to dance wildly before they settle again. But the outcome is strong enough to push against the charged wind of the sun. This geodynamo, as scientists call it, is one of the hidden engines of Earth's habitability. From the movement of molten metal, a global shield rises, unseen, indispensable. Now, is this shield rare, or is it the expected outcome of a planet Earth size? Some researchers argue that it was unlikely, dependent on our planet's particular heat budget, its composition, its early violence in which giant impacts formed both its orbit and its molten state. Others suggest it was a slower inevitability. Any planet of this mass, at this distance from a star, would cool and churn at just the rate needed to sustain a field. In this debate, we find the boundary of chance and pattern again. Was the geodynamo simply luck, or the predictable outcome of physics played out layer by layer? It may help to think of the air we breathe as the upper skin of a body, the soil and rock as the flesh, and the core as the beating heart. Without the heart pumping, the body stalls. The field is the pulse reaching outward, drawing a line where the external assault cannot simply tear in. It is not static. It varies, cracks, and surges, but for billions of years it has held. That time has allowed oceans to settle, air to thicken, and life to expand into vast forms. Remove it, and none of that holds for long. Try to picture walking outside on a field with no shield overhead. Within days, radiation levels would spike to damaging extremes. Electronic systems would falter. Skin and plant growth would fail to thrive. Over longer periods, atmospheric loss would turn the sky thin, blue fading toward pale. Small signs grow to large ones, until Earth looks less like a garden and more like the cold highlands of Mars. The habitability of the planet is not just about temperature or chemical mix. It is about keeping those things in place long enough for life to stitch itself into form. The magnetic field is the quiet guardian of longevity. Auroras remind us of this, faint arcs of light tracing the boundary. They are a marker that the field holds, that energy is being deflected, funneled to safe release. Without them, the full force of storms from the sun would bear down. It is easy to take them as decoration, yet they are as fundamental as the tides or the seasons, evidence of balance maintained. If the magnetic field is our outer guardian, there is a second, quieter one spun from the air itself. High above weather and wings, light and air weave and unweave a filter constantly remade. We give it a simple name, ozone, but names make things feel finished, and this is never finished. It's a living edit of the sunlight that reaches us, a thin correction layer on the day, kinder wavelengths welcomed, harsher ones softened. You sometimes meet a trace of it after thunderstorms, a clean, sharp scent that rides the hush when the rain begins to thin. But most of its work happens far above noses and seasons, where the sky's dry, cold, and still. Up there, the light and the air keep trading small pieces, making and unmaking a film that turns dangerous glare into something bodies can bear. No switch is flipped, no gate creaks open, only a rhythm that holds as long as the dance continues. It wasn't always so. For a long blue morning of Earth's history, the sun's hard light fell with fewer filters. Oceans took the hit, and life stayed low and sheltered. Then oxygen began to gather in the air, and the sky learned a new trick. It could use a little of that oxygen and a little of the sunlight to shape the beam itself. Ozone doesn't prove intention, but it reminds us that filters can arise when chemistry meets light. As the filter thickened, the world's map of where changed quietly. Shorelines moved from rooftop to threshold. Sand no longer needed shade to be safe. Leaves could turn their faces upward. Eyes could open a little longer. Like most of the systems that keep us steady, the filter breathes. Not with minutes or hours, the pulse is slower than that, but with seasons, with the turning of the sun's moods, with winds that slide along high latitudes in winter and relax in summer. Some years, especially in the polar stillness, the filter thins into a wide bruise. It isn't a hole in the way a torn coat is a hole. It is a place where the sift is looser, where certain sharp notes come through stronger. The ground does not ignite. Life is not kindling, but the light has a different edge, and plankton, leaves, and unprotected skin feel that edge before we do. We learned its fragility in a familiar way, by brushing against it and noticing the mark we left. A few of our own useful gases drifted skyward, harmless below, but in the cold clarity of the high air they helped unmake the filter faster than the sky could mend it. Instruments saw the thinning, and photographs taught us to call it a hole. Then, as quietly as the trouble began, people agreed to stop sending those gases upward, and the bruise began to fade. No miracle, just a reminder. We live inside subtle rooms. Sometimes we can damage them. Sometimes, if we act in time, we can help them heal. Think of the ozone layer not as a blanket. Blankets are for warmth and weight. This is a lens. It doesn't hold heat so much as shape the beam, taking the bite out of ultraviolet that would otherwise tear at the small letters of life. Paired with the magnetic field's broader deflection of charged storms, it makes a two-part welcome. One guardian turns trouble aside, the other sifts the light that enters. Between them, much of what would strip air, scorch skin, or hammer at DNA arrives gentled, edited into something the surface can use rather than endure. Stand in an open field at noon and imagine the day without that sifting. The hours outside would shrink to what skin could tolerate. Beaches would be shorter, fields harsher, high places less forgiving. Multiply that feeling across forests, reefs and grasslands, and you begin to sense the scale of what this thin chemistry grants the world. Time. Time for seedlings to push through soil without their cells fraying. Time for eyes, fish, bird, human, to learn light without being scored by it. Time for patterns to repeat enough to become ecosystems rather than experiments that fail too quickly to leave a mark. Ultraviolet is a paradox. In gentle doses it sketches vitamins in skin, sets subtle clocks in leaves, and writes cues that many creatures read without seeing. In heavy doses it is a knife. The filter doesn't solve the paradox, it manages it. It lets a little signal through and holds back the worst of the noise. Not perfectly. Nothing about Earth is perfect in the way a blueprint is perfect, but well enough that living things can take risks. Well enough that a sapling can spend a dry week reaching, that coral can build its slow white cities, that a person can look up and feel warmth rather than warning. If you could watch the high air for a year, you'd see that this is not just light and oxygen, but wind and cold and timing. The filter is strongest and weakest in patterns we have slowly learned to anticipate. In the polar night, unusual clouds form in the clear, dry chill, and the chemistry leans in a different direction than it does in sunlit summer. Winds carry helpful and unhelpful gases toward the poles and back again. The sun itself has moods that colour the rhythm. It's a complicated dance, but its outcome most days is simple, a tolerable noon. All of this is easy to miss because it is invisible in the way most essential things are invisible. You can't see the filter arrive with spring or relax with winter. You only see the colours it leaves behind at sunset and the life that thrives under its care. That is part of its character. Quiet, constant, taken for granted. The lesson is not simply that we are protected. It is that protection can be the result of many small, ordinary rules working together for a very long time. There is a kind of gratitude that comes from noticing invisible helpers. Gratitude doesn't require a story about why they exist. It asks only that we look up and admit how different the world would be without them. A farmer minding the length of the day, a child learning to swim, a colony of algae floating near the surface. Each borrows a little safety from a layer so thin it lives closer to starlight than to soil. The filter is modest, and because it is modest, it is easy to overlook. Our lives are full of such modest rooms. Sometimes the best way to understand a thing is to imagine it gone. Imagine the day with every wavelength arriving uninvited. Imagine a world that has to do everything in the shade. Life would try, because that is what life does, but it would be smaller, tighter, more temporary. The ozone layer does not make life. It grants room for life to become many things before it becomes nothing again. It grants time to copy and repair and try once more. A wall like this matters. It keeps the worst outside and gentles what gets in. But a wall by itself is not a home. It doesn't set the room's temperature or keep the pantry stocked. After the Guardians, the next question is practical. What inside the planet regulates and steadies the climate long enough for living things to risk complexity? That answer lives under our feet, down where rock moves slowly, where oceans trade heat in long loops, where the planet keeps its own kind of weather, and that is where we turn next. Step outside on a quiet evening. The air presses lightly on your skin, thin enough to breathe with ease, thick enough to hold warmth through the night. The sky fades from blue into shadow, and even in that simple act of breathing, you are living inside a narrow comfort zone set by the distance between Earth and the Sun. It feels ordinary because it is constant, yet the constant itself hides just how fragile this balance has been through deep time. Now picture the orbit Earth holds. We circle a star that burns with a steady calm compared with most of its kind. The sun gives off light that neither blinds with flares nor sputters with irregular heat. Year after year, the orbit keeps Earth at a near constant distance, close enough to prevent the seas from freezing solid, far enough to avoid tipping the planet into a furnace. That zone is sometimes called the habitable zone, but it's not wide. It is more a sliver, a band as thin as the edge of a coin laid on its side, and Earth sits tucked within. So let's test what happens if Earth nudges inward, even by a small step. Imagine the orbit drawing closer by only 5%. On paper that seems minor, like shifting slightly in a chair, and yet the results would unfold quickly. Sunlight would increase just enough to change the cycles of air and ocean. Ice caps that now grow at the poles would struggle to hold ground. Seas would warm, and more water vapour would lift into the atmosphere. Vapour itself is a greenhouse gas trapping more heat. The circle begins, heat feeding on heat, and the system races out of control. The image of that outcome already exists. Venus stands closer to the same sun, looking bright in our sky, but concealing a fate that could have been ours. Astronomers studying Venus speak of runaway heat, where oceans that likely once stood on its surface boiled away under a thickening blanket of gas. Temperatures rose high enough to melt soft metals. Clouds formed, not of gentle water droplets, but of condensed acids. Pressures on the surface grew to levels high enough to crush equipment. The feedback did not stop until oceans were stripped, leaving behind a world blanketed in gases that trap heat with no release. Earth 5% closer to the sun begins walking that slope, the line between garden and furnace crossed with surprising speed. Stay with that scene. Seawater turning to steam, clouds building in stacks so dense that sunlight reflects back out while the heat below builds. Land bakes, shorelines vanish under boiling waves, and the oceans themselves begin to retreat as thin layers of vapour blowing outward to space. Biological life, bound by narrow temperature limits, shutters almost instantly. The planet remains, of course, but its surface resets into a harsher state more akin to Venus than anything we now recognise. Habitability fails not by small degrees, but in a tipping cascade. And what if the opposite shift happened? Earth drifting a little further outward. Then the balance tips toward cold. Ice sheets stretch further and linger longer. Feedback begins again, but this time in reverse. Brighter, whiter ice reflects more sunlight, cooling the surface still further, extending winter deeper into the years. Eventually the oceans themselves risk freezing under a thickening crust of ice. Somewhere in between lies the narrow middle, where liquid water endures and temperatures permit complex chemistry. The boundaries of that middle are not wide and vividly precise. How do we explain the fact that Earth sits here, not a step closer, not a step further? One mainstream principle says that of course we find ourselves here, because this is the only sort of place we could exist. This is called the anthropic principle. It suggests that looking for deep meaning in the precision is unnecessary. We only ask these questions because we are in the rare position of standing in the narrow zone that allows asking at all. Most orbits and stars never produce such conditions, but in deep time we happen to live inside one that does. And yet there is another reading. Perhaps the stability is a form of fine-tuning. From across the cosmos, most stars shine unevenly, or burn far hotter and shorter than the sun. Many wander with violent flares. Planets tumble in irregular orbits, some stretched out long and thin, others too close to their stars, scorched barren, or too far, lifeless and frozen. The combination of a calm sun and a near-circular orbit around it is not common. That leads to speculation. Is Earth's orbital setup a coincidence filtered by survival? Or does it hint at a guiding law of nature, some deeper pattern we do not yet see? The thought rises naturally. In a universe full of stars, what are the odds that we orbit one of the gentler ones, within that tiny ribbon where liquid water and breathable air hold steady? Perhaps it is just chance drawn from vast numbers. Perhaps it is more like falling into a slot that seemed impossibly narrow, yet catching it makes all the difference. The very air in your lungs as you stand outside on that quiet evening is the result. Our sun itself sits apart from many others. Compared with the restless stars that flare and waver, it is quieter. It does not lash out with radiance strong enough to scorch atmospheres away, nor does it vary so much that climate swings wildly. This quietness could be dismissed as the fortune of having the right star, or it could be seen as another layer placed one on top of the other, an alignment that goes beyond probability and begins to invite interpretation. And so the payoff is this simple line. To remain habitable, Earth must occupy a razor-thin band of space around a rare sort of star, and we happen to occupy it. That fragility is hidden in our daily feeling of comfort, veiled by the ordinary breath we almost forget to appreciate. The comfort is not given, it is held by precise circumstance, and that circumstance sits in balance because of pathways both cosmic and local. But orbital distance is only one thread in the fabric. Outer position alone cannot keep life steady for long. Other systems must cooperate, adjusting and balancing with patience measured in eons. Stability, after all, does not end with where Earth drifts in space. The ground beneath our feet shifts and breathes in its own cycles, and that restless surface may be just as critical in keeping the planet alive. Before we step down into rock, it helps to watch how the sea quietly moves heat. Even in the right orbit, comfort isn't guaranteed. Where a planet sits is a beginning. How it carries warmth is the rest of the story. Sunlight does not spread itself evenly like paint. It gathers, it thins, it lingers. Something has to lift that unevenness and lay it out more gently. Winds help, clouds help, but nothing works with more patience than the ocean. Imagine rivers you can't see from shore, rivers that run through the water itself. They have no banks and make no sound, yet they loop across basins, slip over the equator, and sink into the dark. Their engine is simple to say and slow to watch: warmth and salt. Near the tropics, the surface is heated and stirred. Farther north or south, that same water meets colder air, gives up some of its warmth, grows heavier, and begins to drift downward. Elsewhere, water rises to take its place, and the loop continues. No valves, no switches, just differences finding balance. You feel the edges of these loops without naming them. A harbour at one latitude is kinder than a landlocked field at the same latitude. Spring hangs on near the coast. Autumn refuses to hurry. The sea keeps a kind of memory, heat stored months ago, even years ago, and releases it later, smoothing the sharpness that bare ground would deliver. For people, that smoothing can be the difference between a winter that pinches and a winter that bites. For forests and fields, it's the steadiness that lets roots trust the calendar. Fresh water falling as long rains or melting from ice can make the surface lighter and less eager to sink in the places it usually would. When that happens, the sea hesitates. A usual dive slows, and storm tracks begin to wander. Lines on a weather map drift in quiet ways that take a few seasons to feel. The ocean does not need to stop to matter. A subtle stall is enough to ask warmth to linger where it used to leave. Earth keeps stories about such moments. Long ago, as great walls of ice were withdrawing, a flood of fresh water seems to have spilled into the North Atlantic and pressed pause on one of those usual dives. Parts of the Northern Hemisphere cooled quickly, winter stepping forward for a while far-off regions heard the change in wind and rain. It wasn't a new age carved over millennia. It was one system leaning on another, and weather across distances feeling the nudge. These hidden rivers move more than warmth. When surface waters sink, they take a breath with them, oxygen from the bright world above, feeding the dim places where light can't reach. When deep waters rise elsewhere, they bring nutrients up with them, and the thin sunlit skin of the sea stirs with plankton. Food webs climb, fish follow. In this way, the conveyor is not only a heat carrier, it's a supply line. Habitability is not only temperature, it is pantry and timing, renewed. Maps can get tangled, gyres, boundary flows, circumpolar swirls, but the principle is easy to hold. Heat travels from too much toward too little, guided by wind, salt, and the shape of the basins. Because the sea holds most of the planet's warmth, these paths act like a throttle on climate. Loosen them, and a downwind coast settles into softer winters and gentler summers. Tighten them, and seasons sharpen. Monsoon edges can shift. Storm corridors can bend. Day to day, nothing looks dramatic. Year to year, a region's personality drift by small degrees. For living things, small degrees matter. A bloom that starts a week early, a frost that lingers a week late. Multiplied, those tweaks become migrations, nests, seed set, and harvest. Follow one parcel of water in your mind. Warm, a little salty. It slides north under birds and boats. It meets colder air, gives up some heat, and sinks with a kind of quiet resolve. Months pass. Hundreds of meters down, it glides along the flanks of underwater mountains, learns the chill, takes on oxygen, memorizes faint traces of where it has been. Years later, under a different moonrise, it surfaces far away. Plankton tastes the nutrients it carries. Winds taste its temperature. Coasts read its memory in their weather. In every part of that loop, something alive uses the steadiness that Parcel helped to write. There is beauty in that patience, and a condition written into it. The system works because balances hold. Enough salt here, enough cooling there, winds that turn in certain seasons, ice that appears and withdraws with a rhythm the water understands. Those balances can drift. A little more melt one decade, a little less sea ice the next. Clouds that linger, winds that shift their routes, a modest change in where heavy water prefers to form, and the lanes shuffle. No alarm is needed to make the point. It is enough to notice that motion is part of what keeps us comfortable, and motion can change. Stand on a pier and watch the tide, and you won't see any of this. The surface looks the same as yesterday. That's the trick of slow systems. Ordinary in a moment, extraordinary across years. But their work is everywhere. A coastal spring that eases in instead of snapping. A summer that lets moisture drift inland. A winter that rarely forgets to be winter. The sea's quiet loops take the accident of latitude and make it kinder than a map alone would suggest. Some worlds might keep their climates by being still and simple. Ours keeps its climate by moving. The conveyor doesn't hum like a machine. It breathes like a long conversation between water and wind, salt and cold. It spreads risk. It buys time. It extends the band of comfort farther along coasts and deeper into seasons than orbit alone would allow. In that spreading, more places become livable, not just for a day or a year, but long enough for roots to anchor and stories to repeat. If you need a single image, picture a hand passing warmth from one side of the room to the other, again and again, never quite the same, never quite forgetting. That is what the ocean does, and much of our ease follows from its habit. The sky can shield, the sea can share. Both help hold the middle ground where life can be many things before it is nothing again. And yet, even a generous handoff of heat needs a partner that works on deeper time scales. Something that does not flow, but lifts and lowers the very surfaces we live on. Beneath the waves and under our feet, the slow machinery of rock keeps its own counsel. That is where we turn next. Picture Earth as a planet where the crust is locked tight. No shifting plates, no mountains rising, no ocean floors spreading outward. Imagine the surface as a single solid shell that never stirs. At first glance, it may sound calm, even gentle, a planet without earthquakes or volcanoes. But in reality, such stillness is a slow sentence for life. Because without stirring, Earth would struggle to breathe. The air would grow thinner over long spans of time, and the slow cycles that hold climate steady would begin to vanish. To understand why this matters, think about carbon itself. On our Earth, carbon flows through the air, through oceans, into rocks, and then back again. Volcanoes vent it into the sky. Rain draws it down into stone. Ocean floors sink, carrying it deep where it melts, only to rise once again. This slow shuffle keeps just enough carbon dioxide in the air to trap heat, but not so much that heat runs wild. On a world with frozen plates, that recycling breaks down. Volcanoes would fade, and once their stores of carbon stop reaching the air, the blanket around the planet thins. The sky cools, the surface freezes, and seas turn to shells of ice. The other possibility is just as grim. If carbon traps inside without release, oceans may choke, air thickens, and the planet bakes under trapped heat. Either path leads away from balance. Now on our living Earth, plates grind, sink, and rise. The outer shell moves piece by piece, slowly but ceaselessly. These motions are what geologists call plate tectonics. Underneath, hot rock moves like a conveyor, bringing new crust to the surface while dragging old slabs back down. Along trenches, plates dive under each other, plunging back into the interior. In mountain belts, plates crash and lift land upward. These motions may seem random violence, but they play a role as subtle as breathing. Carbon dioxide cycles out with every plume of fire and then is drawn down again into stone and water. Too much carbon, and weathering draws it back. Too little, and eruptions lift it again. Over vast stretches of deep time, this mechanism works like a thermostat, keeping the surface within limits. The thermostat analogy is simple. Your home stays temperate because a sensor notes when it drifts, then nudges the heater or cooler. Earth has no sensor, of course, but it has cycles built into its restless skin. When the air warms, rainfall rises, washing more carbon dioxide into rocks. When the atmosphere grows thin, volcanic output tips the balance back. This push and pull keeps Earth's climate within the band where water flows as liquid. Without it, extreme states would grip the planet. For contrast, look to our neighbours. Mars, smaller and long-cooled, has no active plates. Its crust froze early. Without tectonics, carbon cycles ended. Greenhouse gases bled away, leaving it too cold, and much of its stored water locked as ice or hidden deep underground. Venus, on the other hand, shows no evidence of plate sliding and recycling either. That still crust holds heat inside for ages, then releases it in rare, catastrophic sweeps. Greenhouse gases choke its air, trapping heat without relief. The lesson is clear. Where tectonics fails, balance tips, one planet freezing, the other smothering. Between them sits Earth, restless but stable, breathing just enough to stay alive. Think of tectonics as a lung-moving layer by layer. It exhales when volcanoes release gases. It inhales when stone draws carbon down. Over millions of years, these breaths add up, regulating skies far more steadily than any short cycle the atmosphere can manage on its own. This is why habitats form and last, why forests grow year after year, why seas hold their range of a life. In stillness, that lung would collapse, but in motion, Earth's skin works like a great slow-burn engine. And still, questions remain. Is tectonic movement inevitable on a planet our size? Or was Earth's rhythm an accident of heat, water, and composition? Some argue that once a planet reaches a certain scale, its insides must churn. Others see Earth as unusual, an outlier. Too small like Mars and heat fades too quickly. Too dry, and plates are locked in place, friction too strong to allow them to slip. If water lubricates the surface, then perhaps Earth's oceans made plate tectonics possible in the first place. That would mean our steady engine rests on multiple coincidences, all stacked together. When you pause to picture it, tectonics is not just geology, it is survival. Every tremor underfoot, every mountain built, every deep ocean trench marks the system that keeps gases balanced. It is not neat or quiet. Earthquakes take lives, eruptions rearrange land, tsunamis strike without warning. And yet, these same processes are what hold the atmosphere in place over eons. They are the slow machinery on which stability rides. Without them, short-term peace becomes long-term collapse. That raises a longer thought. Is Earth's tectonic breathing unique? One rare alignment in the cosmos, or is it a recurring pattern across countless worlds? If it is unique, then the balance we live within is rarer than we often admit. If it is common, then perhaps Earth is not alone in holding this hidden rhythm. Either way, its importance cannot be denied. For as long as the plates have shifted, life has endured through ice ages, warm periods, and mass extinctions, adapting not in spite of tectonics, but because tectonics kept the climate within bounds wide enough for resilience. We can think of tectonics as the quiet scaffolding of habitability. Mountains rise, weather into sand, those sands lock away carbon, plates draw that carbon down, and the cycle begins again. Layer by layer, rock writes a slow story of endurance. Earth's skin, restless, scarred, keeps a balance we mostly walk past without noticing, a balance that helps hold the air steady enough for lives to stack. In the long ledger of chance and necessity, tectonics reads like a deep-time ally. Up close it can be violent, across ages it feels steady. The alternative is a still crust and a world where balance drifts. It may be closer to the truth to say, part of what keeps our planet lively is that its crust moves. Those movements keep the great cycles in motion, not perfectly, but long enough for forests to rise and seas to remember. Even so, rock alone doesn't carry the weight. The wider system only works because it is paired with water. Carbon can return to the sky only if air and sea answer each other. Plates can slide only if a softened layer, helped by water within and above, lets them. Which is why Earth's slow breathing ties directly to water's stranger habits, and why those habits might be the quiet anchor that holds many other systems together. Before we talk about the strange kindness of water itself, it helps to notice how the sky keeps a set of mirrors. Imagine standing on a snowfield at noon, the light almost too bright to face. Then turn toward open ocean, dark and calm, where the same sun sinks into blue without glare. You can feel the rule without naming it. Some surfaces send light back to space, others drink it in. The planet changes its mind about brightness every day, and that choice sets the tone for the weather we live inside. Clouds are the most restless mirrors. Low, wide sheets can soften sunlight like gauze, sending much of it back upward before it warms the ground. High, thin veils behave differently, letting light in by day and, after dark, lingering just enough to hold some warmth close. None of this is precise like a switch. It's a conversation between droplets, crystals, sunlight, and air that is always in motion. Even so, from far away you'd see a simple habit. On cloud-rich days, the planet looks paler. On clear days, it looks darker. Paler days tend to cool a little. Darker days tend to warm a little. Small tilts, multiplied, become seasons we recognize. Ice and snow are steadier mirrors, but they move too, advancing and retreating along the edges of continents and over seas that remember winter differently each year. A fresh snowfall draws a bright line across a map telling sunlight to return to the sky. When spring roughens that surface and darker ground reappears, the same sunlight is invited in. At sea, the hinge is sharper. White ice sends light back. Open water keeps it. The edge between them can feel like a small thing when you stand beside it. From above, it is a change in how much of the sun the world keeps. These mirrors talk to temperature in loops. Cold grows ice. Ice brightens the world. The bright world cools more easily. Cold keeps its ground. Warmth melts ice. Dark water appears. Dark water drinks light. Melting continues. The loops rarely run one way for long. Winds arrive, storms shuffle the deck, seasons lean in with their own logic. But a small nudge can help a mood linger. Sometimes faraway events send new mirrors into the sky. A volcano clears its throat beyond the horizon, and tiny particles climb into the high air, each one a seed for a brighter day. Sunsets bloom for a season. Afternoons feel faintly dimmer. Months later, as the air clears, the world returns to its ordinary face. We might never learn the mountain's name, but we will have lived beneath its temporary veil. Forests can tip the brightness too, though not in a way you'd notice from a single hill. Fresh leaves darken a region just enough to welcome more light. Old snow lying unbroken on empty ground brightens it. The pattern is never even. A wet spring here, a dry winter there, a lake that freezes later than usual, a field that stays green into autumn. Each patch answers the sun in its own way. Together they make the planet seem to smile or frown, a little at a time. We often speak of comfort as if distance from the sun or the planet's tilt were the whole story, and they matter. But day by day, comfort is negotiated by reflectors that move. A bank of low cloud turns a harsh noon mild. A thaw trades a field of mirrors for dark, wet ground that drinks the next clear day. Along coasts and over plains, these shifts can slide storm tracks by a few miles, stretch a frost by a day, coax a sea breeze inland, or hold morning fog long enough to keep leaves from burning. Small adjustments felt by root and wing and skin. The simple idea is this. Brightness decides how much of the sun stays. The sky and the surface decide brightness. We live inside that decision. The planet's mirrors are about more than temperature. They're about timing. The difference between rain that comes in the afternoon or the night, between a bloom this week or next. When light returns to space, the day leans cool and gentle. When it's kept, the day leans warm and quick. Creatures carry calendars stitched to those leans, and the calendars do not all agree. Some years one wins, some years the other, but none of them are wrong. They're just reading the same light through different lives. It's tempting to name every cloud and map every kind of ice, but the heart is easy to hold. Bright surfaces cool, dark surfaces warm. The planet changes how bright it is, and in changing brightness it changes us. The details matter to those who measure for a living. For the rest of us, it may be enough to look at a winter field, then at an open lake, and know that those two worlds, side by side under the same sun, are making different choices with the same gift. There's a kind of humility in watching light leave. It reminds us not every warm hour is kept, that the world edits as it goes. Some of that editing rests in our hands. Forests we keep or cut, soot we send up or refuse to send, snow we protect with shade, small levers among larger ones, leaning the same way as the sky's mirrors. They don't prove intention, they remind us comfort can be tended. If rock shows us the machinery underfoot that sets the stage across ages, land lifting and lowering, then the mirrors above are the stage lights, turned up or down by air and water, ice and leaf. They don't change the script alone, but they change how the scene feels. And with the lights in mind, we can step closer to the actor that makes these choices matter most. A small, stubborn molecule whose quirks let lakes float. Storms carry heat, and living things hold together long enough to matter. What if ice sank instead of floated? It sounds like a small tweak, but it would shift the story in a way that's hard to undo. Picture a lake in winter. Today, it skins over, a thin lid forming above liquid water. That lid insulates what lies beneath, letting fish and plants pass the frozen months alive. If ice sank, though, the story would run backward. New ice would form, sink, and make way for more. Layer by layer, lakes would fill from bottom to top until nothing lived there at all. When spring returned, they wouldn't thaw. Their depths would already be locked. Rivers would follow, seas too, frozen from beneath. Life in water would be smothered long before it had a chance to try for shore. This thought experiment points to something odd about water itself. Most substances grow denser when they freeze. Water refuses. Its solid form is lighter, so it rests on top. And that simple trick has shaped ecosystems for whole epochs. Fish survive winter because ponds do not freeze through. Algae recover each spring, rising from liquid beneath the ice to restart the food web. Lines of survival that feel permanent began with a quirk at the molecular scale, a kindness that lets time continue. Now let's stretch further. What if water also lacked its ability to hold heat the way it does? Today, oceans act as huge buffers. They absorb heat during the day and let it out slowly at night. Across seasons, they hoard warmth in summer and share it during winter. Without this, climate would swing fast and violently. Days would scorch, nights freeze, years tip from extremes so quickly that stable life zones would vanish. Water's high capacity for heat turns seas into thermostats. Not perfect ones, but forgiving enough to keep temperatures within the ranges that let DNA and proteins function. Without it, Earth's skin would burn and chill in alternating pulses. Stability, the kind life requires, would not emerge. The reason for all this circles back to hydrogen bonds. Each water molecule is shaped like a bent triangle, with two hydrogen atoms tugging at opposite ends of an oxygen. That geometry lets molecules stick to each other in a delicate dance, constantly connecting and breaking apart. When water freezes, those bonds lock into open lattice structures, making the solid less dense than the liquid. When it warms, those same interactions give the fluid resilience, absorbing heat without rushing to boil or freeze. Out of that invisible structure, whole continents of climate find balance. It is less dramatic than tectonic plates or giant impacts, but no less decisive. Test the system in imagination. Picture an ocean with weaker bonds, a hot day, and whole stretches of water boil away in hours. A cold night, and coastlines crack under sheets of sudden ice. Life tries to root in such change and fails each time, or reverse it. Strengthen the bond so water clings too tightly. Then it resists evaporation, rainfall falters, and circulations that now carry warmth and nutrients across the globe stop moving. Weather collapses into stasis, water no longer flowing as Earth's blood. Each small variation in bond strength drives the world into extremes. The difference between chaos and habitability hides in millimetre scales at the atomic level, so what sense do we make of this? Mainstream chemistry points to structure, not miracle. Molecules arrange in ways consistent with physics, and water's shape simply sets its path. Under this view, oddity is not purpose, it is mechanical inevitability. Design-minded thinkers answer differently. They see in water's quirks the look of fine-tuning. How many common liquids expand when they cool and freeze at the top? Very few. How many can absorb vast amounts of heat without snapping? Rare again. Stack these peculiarities together, and water does more than refresh or clean. It steadies climates, buffers ecosystems, and shelters fragile life forms against environmental violence. To some eyes, that feels more like arrangement than whim. And yet the cautious answer lingers. Perhaps with billions of galaxies, each with countless stars and planets, the emergence of one liquid with these properties is not shocking. In this frame, water is unusual but not unique, and we only notice it because our survival has always been bound to it. Once again, the boundary between design and necessity stays blurry. It is a tension woven again and again into Earth's story. We survive not because conditions are common, but because they hold us here long enough for life to stack complexity atop quirk. Think about how much of nature depends on this trick. Lakes thaw back each year. Oceans buffer monsoons and droughts. Glaciers float instead of sinking, steering currents and sea levels. Even our blood carries these bonds in each drop, regulating warmth and flow. The same molecular rules that steady seas also stabilise the chemistry inside our bodies. Water's quiet trait scales outward, from cells to continents. It speaks both of fragility and resilience, the sort of balance that feels almost scripted in its reach. And maybe that is the striking part. When we step back, tectonics moves the crust, the magnetic field shields the sky, the moon tugs on the seas, and water itself, molecule by molecule, preserves stability inside. Life demands all of these together, and without anyone the balance slips. Water, though, works differently. It does not operate by brute force, but by fragile geometry. A slight change in bond angle, and the planet would not be what we know. That quiet, hidden factor regulates everything we call ordinary. Sit with that for a moment. Every time you drink, you rely on hydrogen bonds forming and loosening. Each winter when a pond ice is over, those bonds hold back a quiet collapse. Vast seas scooping sunlight store and release it because of them. Through this lens, one of Earth's most faithful allies is not dramatic at all. It's the plain fluid we almost forget to contemplate. Chemistry can trace how this happens in tidy symbols. What it means invites gentler readings. To one eye, it's simply molecules settling into the shapes they must. To another, it hints that even common matter carries odd alignments of surprising benefit. Both views can sit together. Either way, water is not ordinary. It is the steadying hand that keeps life from jolting back and forth with every change of light or season. Balance, though, does not end with bonds or tides or rock. Water can cradle and smooth from the outside, but weather is also written from the ground up by living things. Before we step inside a cell's script, look at how life gathers water, uses it, and sends it on. How forests learn to keep the air from wandering away. Picture a hot afternoon at the edge of a green country. Air drifts in from the sea, heavy with moisture. As it meets the first ranks of trees, the ground roughens, wind slows a little, and leaves begin their quiet labour. You can't hear it from the road, but every leaf is sending a thin thread of water skyward, drawn from soil, lifted through wood, brushed into air as vapour. A single tree is a small fountain, A forest is millions, speaking at once. That rising breath does two things. It cools the shade and thickens the air above, making it easier for clouds to gather. Some of the same compounds that make a pine stand smell sharp in evening can give droplets an easier way to find each other, soft invitations for clouds to deepen. None of this works like a valve. It's more like a conversation between land and sky. Over hours, that conversation can tilt the day. Breezes that might have hurried inland pause. Moisture that might have slipped past begins to build. The green edge becomes a hand that catches passing humidity and lifts it. Follow that air farther, and the picture expands. Moisture does not simply cross the shoreline, rain once, and leave. It can be caught, used, and sent again, step by step into the continent. Rain falls, forest drinks, forest breathes, cloud gathers, rain returns. In some places, people call these flying rivers, long unseen streams of vapour flowing above the canopy, feeding lakes and fields far from the ocean they began over. Stand in farmland downwind, and the afternoon shower that saves a crop may have started as vapour lifted by trees hundreds of miles away. Shape matters. Tall roughness slows wind just enough for air to settle and build. Deep roots keep drawing even when the surface dries. A living floor returns moisture to the sky after a storm instead of letting it rush away. Over days, that steadiness becomes more late-day clouds, more gentle rain, fewer sharp swings. Over years, it can be the difference between a place that browns and a place that stays a mosaic of greens through long summers. When the forest thins, the conversation changes. Fewer leaves mean fewer threads rising. With less roughness, wind hurries inland without pausing. Rains visit in shorter, harsher bursts, or pass by entirely. The land warms more by day and cools more by night, and the calendar of plants begins to misread the signals. Seeds that counted on afternoon showers wait longer. Streams fall sooner. Trees don't make rain in the way a switch makes a light. They give the sky more chances to say yes. From high above, seasons sketch this plainly. In summer, broad belts of northern forest draw moisture inland, and clouds bead along the line where green deepens. Far to the south, a continent-wide canopy exhales, and storms bloom in the late afternoon like a pulse. Break too much of that canopy and the pulse weakens. Rains arrive less often, or at the wrong time. The country downwind, farms, marshes, towns, feels the difference without ever seeing the exact thread that was cut. There's another lever in the woods: shade. Under a closed crown of leaves, the ground is cooler. Less water evaporates straight from soil, and more stays in the long loop through wood. Shade is a kind of unhurriedness. It slows the day so water can be used twice, once inside the leaf, once in the cloud that returns to fall. A field in full sun drains fast. A forest sips, then breathes. All of this rides on water's oddities, the same quirks that let ice float and storms carry heat. Because water holds energy well, the air above a living canopy avoids the sharpest spikes of noon and the steepest drops after dusk. Because water can change form with ease, a small rise in vapour can become a cloud without much pushing. Trees don't bend physics. They live in its soft corners. They lean the weather a little towards staying. It's tempting to turn this into numbers and arrows, to tally millimetres of rain and watts of heat. The counting has its place. For the rest of us, it may be enough to step from bare ground into shade and feel the air thicken, to watch a small cloud bud from green in late afternoon. A forest may not cause that cloud in the way a switch causes a light, but the day often acknowledges the trees. None of this makes forests a cure-all. The sky keeps its own moods, the ocean its loops, mountains their habit of pushing air upward. Some days the larger pattern speaks louder and the local conversation goes quiet. But give trees time and a wide enough canvas, and their habits add up. They stitch moisture to land. They borrow a little rain from tomorrow and send it gently today. They make interiors less dry than they might be, and coasts less storm-torn than they could become. There is a human scale to this. Towns downwind of long forests learn to expect late-day showers that keep gardens alive. Farms lean on afternoons that pull a breeze across rows without baking them. Reservoirs fill by a series of small, regular gifts rather than a few floods. These aren't promises, but habits. A rhythm you can usually trust until too many threads are cut. What forests do to light and air echoes what we saw in the ocean. Motion spreads comfort. The sea passes warmth. Trees pass water. Both turn accidents of place into more livable weather. Both are modest in an hour and decisive across seasons. And both, once thinned or stalled, take time to learn their old ways again. If you stand among trunks when the day is ending, you sometimes feel the air lift around you, as if the whole grove were exhaling. A few hours later, a soft rain may arrive from a sky that looked empty at noon. Patterns like that invite a different way of seeing, one in which life doesn't merely endure the weather, but quietly helps right it. Hold that thought and something else comes into view. Pick up a shell and trace the curl with your thumb. Turn a pine cone in your hand and notice how the scales seem to lean in two crossing spirals. Walk a field and watch sunflower heads write quiet order in their seeds. Then look down from a hill and see a river bend as if remembering the same curve. The world keeps drawing certain shapes. Hold a leaf up to the light and look closely. The big veins branch into smaller ones, then into threads that seem to know exactly when to stop. If you trace them with a finger, you can feel a quiet fairness at work. Every patch of green gets a share of water and sugar. No corner is left too far from the road. Maps drawn by need. Set the leaf down and look at a giraffe's coat. The shapes are not perfect hexagons or tidy squares. They're a loose hive of cells that fit together without gaps. Look again in a different place. A dragonfly's wing. A dried riverbed, cracked paint on an old fence. The world keeps sketching networks, lines meeting lines, until a surface is divided into rooms that can share. There is a common habit beneath these different faces. Imagine points sprinkled across a space, each claiming what is nearest, each growing until it touches a neighbour and must stop. The result is a patchwork that looks as if it were planned, though it grows from nothing but mine until yours. Leaves do this so every cell can be served. In the skin of fruit and the hide of animals, the same habit lays out efficient neighbourhoods. Even stone listens. As lava cools and shrinks, stress wants to spread evenly. The surface divides into columns that often lean towards six-sided. Basalt cliffs and old causeways look as if a mason came and laid them. Yet they are just the rock's way of sharing strain. Not all order is made of lines and rooms. Some of it appears as pulses and bands, born from simple chases. Picture two whispers in a shallow sea of chemistry. One says, "More of me." Another says, "Not here." The first spreads and thickens. The second runs faster and thins it out. The first surges again where the second has passed. Out of that small contest come stripes and spots, zebra and angelfish, leopard's rosettes, the delicate dots on a fawn. On a shell, the edge that grows keeps a record of these chemical murmurs day by day, and the pigment prints a barcode of the creature's life. A dark band when more wins, a light band when not here gets ahead. No architect stands over it. Rules whispered in the right order are enough. If you prefer water to skin, watch foam after a wave collapses. Bubbles crowd one another into hexagons, the cheapest way to pack circles on a surface. If you prefer sand to foam, walk a dune field and see the wind write evenly spaced ridges with its own back and forth. If you prefer ice, stand where a pond is just beginning to freeze and notice the crystals reach out in branching arms, each new line copying the angle of the last as if remembering. Different ingredients, different scales, the same instinct. Grow by repeating what worked a moment ago. Stop when you meet a neighbour. Try again in the open space. What's striking is how often good enough looks beautiful. The sunflower's head is not aiming for an equation. It is simply trying to pack seeds without wasting light. Turn the head in your hands and the eyes find two families of spirals crossing, one set leaning left, one right, because that is a strong way to fit as many seeds as the circle will allow. A river does not intend an S-curve. It is looking for the easiest fall, cutting softer banks, laying its weight where the ground yields, then yielding back. Beauty arrives as a side effect of thrift and ease. There is comfort here, and a kind of humility. Order can arrive without a planner. Give a space some simple local rules, share evenly, grow until touched, copy a successful angle, let one signal outrun another, and patterns will write themselves, the way frost writes stars on glass. The leaf doesn't see the whole leaf, the river doesn't see the valley. Each decision is small and nearby, but together the decisions rhyme. Stand in a field and turn slowly. You can find these rhymes everywhere once you start looking. In the way grasses lie after a steady wind. In the way barn swallows tilt and turn to avoid one another without colliding, holding a moving lattice in the air. In the way cities from above begin to show veins and blocks and rooms of their own, as if our building were an echo of branching and dividing we learned from the land without meaning to. Patterns are habits that space falls into. Of course, the habits change as conditions change. Add more moisture, and the lines in mud move farther apart. Tilt the sun lower, and a plant adjusts the angles where it places new leaves, so shadows overlap less and light has room. Cool a rock faster, and the columns come out thinner. Warm ashore, and the dune crests walk inland. Even the stripes on an animal can shift with small differences in how warmth or food arrive while it grows. None of this is rigid. It is preference, not law. Sometimes the habit that a place prefers can be learned in a single afternoon. Other times it is written only slowly, across many seasons, until even the patient forget that a different pattern was possible. This is why you may think a coastline always wears scallops of bays and headlands in a certain rhythm, until a storm redraws them. It is why a forest looks fixed until insects, drought and recovery rearrange its rooms. The same rules can draw different pictures, given time. You can let all of this be wonder and stop there. Or you can ask the next quieter question. If patterns can rise from local rules, where do the rules come from? The leaf's fairness is built from how cells talk to one another at just the right hours. The animal's stripes come from small signals turning on and off in precise places while skin is still being made. The rock's columns come from atoms taking the places that feel least strained. Somewhere close to the centre of those choices sits a library of instructions. Starts and stops, if this then that, try again here, that living things carry inside and consult without looking. We don't have to open the library all at once. It's enough, standing in a field with a shell in hand and a river below, to admit that simple habits can draw complex pictures. But if the pictures are so reliable that swallows can stitch the sky without meeting, that leaves can feed their farthest corners, that coats and shells can print stories as they grow, then something inside must keep time and keep order when noise arrives. Something must forgive small mistakes so the pattern can continue. That something is not a magic word. It is a script, a way of saying make a stripe here and stop a vein there, fold this, repair that. Wait until the light changes. It lives in letters too small to see, carried in almost every cell. It is not perfect. It bends and it mends. But because it exists, the world's preferred shapes don't have to start from scratch every morning. And so the next step is closer and smaller. We've watched rivers in water and rivers of air, and we've watched leaves and coats and stone choose their favoured lines. Now we can step inward to the pages that help those choices happen, and to the quiet ways the pages protect themselves when the world smudges the ink. What if the recipe for life had been written sloppily, full of stumbles and slips? Imagine instructions inside every cell that scrambled at the slightest stress. proteins would be misshapen, cells would fracture, and organisms, if they formed at all, would collapse under the weight of broken code. Life, instead of flourishing across oceans and forests, would vanish almost as fast as it began. That thought pulls us into the secret world of DNA, where the script of biology is stored with surprising care. DNA works like a text written in 4 letters, repeating in long chains, but unlike a random scrawl, it carries a sort of grammar. It is not only what letters are present, but the order and spacing that matter. When read, this sequence of letters shapes proteins, and proteins then shape everything from hair to hemoglobin. If the grammar slipped often, then proteins wouldn't fold correctly, instructions would collapse, and organisms would stumble before they had a chance to endure. Instead, DNA contains small systems of error correction, mapping back and checking, like a careful scribe reviewing each line copied by hand. Now think about life with no proofreading. A ribosome, the tiny reader inside the cell, would latch onto a strand of RNA and begin its translation. But without accuracy, each read might miss, each copy might stumble. Imagine books where every 10th word mutated into nonsense. You might stretch to follow along, but the meaning would blink in and out. Cells are even less forgiving. A single misplaced instruction can split proteins open or freeze their function. Without resilience built into the system, even slight changes would wreck the possibility of complex life. What we see instead is different. Ribosomes read code with remarkable precision, handing off instructions to assemble proteins in order, step by step, like a machine threading beads onto a string with almost no errors. This translation repeats trillions of times across your body each day, rarely faltering. Mistakes do happen, but they do not dominate. That difference between collapse and resilience creates the room for multicellular life to rise, to grow, and to pass traits down across generations. The scale of accuracy here is not an afterthought, it is central, and the reach of this code is wide. Nearly all known life, whether bacteria, oak trees, or whales, shares the same basic grammar. The 4 nucleotides, adenine, thymine, guanine, cytosine, are used universally. More than that, the rules for translating pairs into proteins are nearly identical across the spectrum of life. It suggests that long ago one system found a way to write, and every lineage since has kept the same alphabet. Think of it as finding a universal dialect, used across everything living, from the simplest cells to the most complex animals. The spread of such universality is striking, as if the first script was already close to optimal. Some researchers have suggested that this grammar is not only stable but unusually efficient. When you compare possible codes, variations of rules for mapping sequences to proteins, the one life uses today resists mistakes better than many alternatives. A substitution in a letter often leads to a smaller shift in the resulting protein, rather than total collapse. It is as if the code was oriented not to avoid change, but to withstand it when it came. That resilience increases the odds of survival. It allows evolution to experiment without wiping the slate clean at every mutation. In this way, the code is not brittle. It's both precise and forgiving. The question rises, why this code? The mainstream answer is convergence. Through the rough march of early evolution, one robust system survived while weaker ones faltered. Once in place, it spread, locked in by the advantage of resilience. From this view, the elegance is not intent, it is the outcome of billions of trials. Other systems may have existed, but only this one endured. The fact that we find it universal may simply reflect survival bias, the same way we consider Earth lucky because it sustains us at all. Design-minded thinkers tilt the lens differently. They see in DNA's resilience the appearance of optimization. A code so resistant to error and so nearly universal suggests something more than brute trial. It feels like an arrangement that was guided, whether by deeper laws of physics that favour information stability, by a purposeful pattern, or by some form of inherent order in the cosmos. They would say the fact that DNA seems like one of the most efficient codes possible raises the possibility of intent hidden inside molecules. To them, DNA is not just a survivor, but a signpost of design. The debate runs in tension. On one hand, DNA's robustness seems like convergence demanded by survival. On the other hand, it radiates a kind of uncanny aptitude, that the genetic language lining every cell seems fit not just to hold life, but to endure across deep time. No other code is in use across the planet, despite billions of species and forms. That unity alone challenges us. Was it locked in by accident, or does it speak of a foundation deeper than accident? You could see it as a library. Imagine shelves filled with countless alphabets, some clumsy, some elegant. Early in history, life had access to many. But once one particularly sturdy alphabet began to spread, it set the standard. From then onward, everything written used the same letters. In this analogy, we inherit a language optimized for meaning and durability. Was it chosen randomly by chance alone, or was it the only one flexible enough to persist against mistakes? For us, the effect is simple but immense. Your very survival hinges not on the beauty of sunsets or the form of galaxies, but on the resilience of a four-letter code written billions of years ago. The lush diversity of the biosphere traces back to its structure. The rhythm of breathing, the repair of tissues, the inheritance of traits, all rely on DNA's quiet precision. You carry this script without noticing, but every cell in your body is proof of its staying power. And the takeaway here is not that DNA is flawless. It permits errors, but it bends rather than shatters. That structure lets life change, adapt, and branch across eras. Without it, stability would not last, nor would history run so long. The silent script is both grammar and safety net, weaving resilience into every generation. Its elegance is a quiet partner to everything we think of as natural. So, does this point toward necessity or arrangement? The safe answer stays with convergence. The speculative one suggests tuning. Either way, DNA's design adds to the sense of improbability that hangs around our existence. Just as water holds unlikely physical traits that shelter life, so too DNA holds unlikely information traits that secure it. Both combine to steady a fragile planet across deep time. The mystery of efficiency does not stop inside the cell. We saw repeating motifs woven into seashells and galaxies. We see resilience tuned into molecules. Together, they suggest that the world's forms carry hidden structures, whether born from chance or law. So the next question emerges: if DNA is the silent script within, then perhaps math itself is the silent script without. The geometry spun into rivers, branches, and stars. And beyond those shapes there is a slower script still, not lines and spirals, but clocks. Stand on a wide plain at dusk and feel the day lean toward cool. That lean is a small clock. There are larger ones, too patient for an evening to reveal, that move shorelines, slip forests across continents, and tell ice when to sit down and when to rise. We live inside their timing whether we notice or not. The planet does not only circle, it changes how it circles. Sometimes the path stretches a little and then relaxes, as if the ellipse were breathing. Sometimes the whole world nods, tilting its face a few degrees more toward the sun and then a few degrees less. And sometimes the spinning top of Earth wobbles, turning the pointer of seasons slowly around the horizon. Stretch, nod, wobble. 3 quiet motions layered on the year. They don't argue with spring and winter. They lean on them, nudging where summer lingers and where snow keeps its ground. You won't feel a wobble from one spring to the next. Stack many lifetimes and coastlines begin to answer. A glacier that once held a valley lets go. A desert hesitates at its edge. Monsoons step farther inland or arrive a little sooner. The line where snow survives all summer walks north, then south, like a seamstress taking and letting out a hem. Over tens of thousands of years, these small tilts and stretches add up to a climate with a different personality, and landscapes learn new habits. These long clocks don't act alone. When summers soften in one hemisphere, snow lingers more easily there. Lingering snow brightens the ground. A brighter ground shrugs off heat. The next winter arrives a little readier to hold what it wins. Where summers sharpen, ice loses its grip. Dark water appears and drinks light. The next summer begins a step ahead. A nudge becomes a trend. Air and stone keep their own ledgers. When grass pulls back, dust rises. It seeds clouds, and even faraway seas answer with a faint bloom. A little carbon leaves the air, the surface cools a hair, and winds shuffle the map. None of this is precise like a switch. It is a conversation among ice and light, plankton and wind, each answering with the tools at hand. Oceans remember the longest. When summers lean hard in one hemisphere, deep water can surface more easily in certain places, carrying long-stored nutrients and long-stored breath. Storms answer with new routes. Coasts notice a familiar fog arriving in the morning instead of the afternoon. Far inland, rain tracks wander a few valleys over, and a forest that kept a particular rhythm for centuries learns a new beat. Watch a single bay for 50,000 years, and shorebirds would lose and find the same strand line many times, each return feeling like the first. For living things, these clocks open windows and close them. A grassland corridor unfurls between ice and forest, and hooves follow it, to new water, new forage, new hazards. Softer winters give trees time to climb a slope they could never hold before. Harsher summers ask them to back away. Some species take the hint and move. Some plant their feet and pay the cost. In the record left behind, pollen caught in lake mud, shells layered in old beaches, dust tucked into ice. Those choices read like lines in a diary. You can hold a piece of that diary in your hand. A core of ice from a high, cold place keeps bubbles of ancient air. Inside them, the breath of earlier summers and winters still rests. A cave remembers in stone. Drip by drip, a column grows, and its thin layers hold the signature of rainy years and dry ones, warm decades and cooler stretches. Even the shells of tiny sea creatures settle into the seafloor with a faint echo of the water they grew in, a chemical nod to how the ocean felt the sky. It is tempting to turn these patterns into promises. This tilt means that climate. The safer story is softer. The clocks are patient, but they are not dictators. Volcanoes speak and lift new mirrors into the sky. Continents drift underfoot, reshaping basins and rerouting currents. The sun has moods that blush the edges of these long rhythms. What the clocks provide are opportunities, chances for ice to advance or retreat, for deserts to reach farther or pull back, for rains to set up camp in a new place for a while. Still, the outline is clear enough that you can feel the planet breathing if you look from far away. Glaciers step forward and kneel back. Rivers braid, choose a single path, then braid again. Coasts build dunes that walk inland for a few centuries, pause, and then walk back. In one long phase, steppe and savanna stretch their fingers. In another, forests knit them together. These are not tidy cycles that repeat like clockwork. They are preferences that come and go when the three motions align, are amplified, or are quieted by things the clocks don't control. For our kind of life, some preferences are generous. Warm, steady summers that don't overreach, rains with a dependable pulse, winters that keep pests in check without breaking the bank. Periods like these let complexity accumulate. Other preferences are stern. A few degrees the other way and ice finds a new beachhead. Dust rides higher, fires run wider. A valley that once welcomed travellers grows dry. A high pass opens where ice has stepped back. Routes close, new ones appear. There's a paradox in these clocks. They're gentle in any given year and immense across ages. They wound and they mend. They erase and they invite. Ice scours valleys. Its retreat leaves soils young and eager. Rains shift and a lake closes its eye. The echo of its shoreline becomes a ring of rich ground for birds and people. A corridor opens and carries travellers into a new corner of the world. When it closes, those travellers become natives. The same hand that tightens, loosens. Some rhythms are weather, soft and passing. Some are turning points. The next pages belong to those sharper chapters, moments when patient nudges were not enough, and the planet wrote in bold, air remade, oceans reset, ice from pole to nearly everywhere, and then along thaw. It may be that the very disasters we think of as endings were also chisels, carving new forms into being. The idea resists our instincts. Catastrophes sound like closures, shocks that break patterns, erase species and strip stability away. But read the rock like a book, and another possibility appears. After the hardest chapters, the next pages often grow crowded with new voices. Collapse clears the canvas, and something unexpected learns to paint again. Consider the broad strokes of that story. Asteroid strikes throw debris into the sky, darkening light for months or years. Ice ages advance, locking continents under sheets of frozen water. Volcanoes erupt with force, pouring ash across hemispheres. Each is a genuine disaster in its own scale. Whole lineages vanish, ecological webs snap, and balance collapses into chaos. Yet when layers of stone are read like a ledger, what follows in the strata above is not uniform silence. New voices gather where silence should have been. At a fresh road cut, trace the rock where rain has rinsed it bare. Dark bands, then pale, then dark again. Iron laid down in stripes, as if the ocean once breathed with slow, rusty lungs. Early waters carried dissolved iron the way a kettle carries heat, quietly, invisibly, under a sky with almost no free oxygen. Then, in bright shallows, small makers learn to use sunlight not just for warmth, but for work. They split water, stitched carbon into sugars, and the world received a new byproduct: oxygen. Oxygen is not a gentle guest. It binds what it meets. In those first patches, it seized iron out of the water and dropped it as flecks, red snow settling to the seafloor. Layer by patient layer, those flecks became stone, banded iron formations we can still hold in a hand. You can read the bands as pulses, times when oxygen production surged, then eased, then surged again, the sea clearing itself one stripe at a time. At first, oxygen was trouble. Microbes built for the old chemistry found the new air harsh. Coves that turned slightly modern became difficult homes. Some lineages retreated to mud and darkness. Others learned to live with the intruder and eventually to use it. For those that did, the reward was energy. Breathing oxygen let cells wring far more work from food than before, extra strength in the same daylight. Over long spans, that surplus funded new experiments. Bigger bodies with more rooms, partnerships between cells, patience for complexity. The sky answered too. As oxygen gathered, sunlight began to weave a thin shield high above, turning raw ultraviolet into kinder light. Day by day, nothing looked miraculous. Century by century, a margin for trying grew. There was a price. Oxygen tugged methane from the air, thinning a blanket that had kept the early planet warm. Winters lengthened, ice pressed farther down valleys. In some tellings, the ease for ice sharpened so much that bright spread on bright, and the planet leaned hard toward white. The sea had learned to breathe, and the world almost held its breath. That oxygenation chapter sits deep in time. Much later, another extreme arrived, the long white. Imagine standing at what should be a tropical shore and feeling the wind bite. Clear ice has swallowed the beach and wandered out over dark water until even the horizon looks pale. The sun is there, but the planet has turned itself into a mirror. Evidence for such scenes whispers from stones called drop stones, lonely boulders dropped into fine mud where only rafts of ice could have carried them, and from sudden cap carbonates that sit above the ice age layers like bright lids, as if warm, carbonate-rich seas had returned in a rush. The record hints that Earth went very white, then very blue, more than once. How does a planet get there? Not by a single shove, but by a loop that tightens. Snow spreads and reflects more light. Reflected light cools the day. Cooling grows more snow. Seas that would normally drink sunlight are hidden. Continents that would darken in summer stay bright. Winter stops giving back what summer asks. The mirror strengthens. While the surface hardens, the inside keeps working. Volcanoes breathe carbon into the air. In ordinary times, rain and fresh rock would draw that carbon down and tuck it into stone. But under a lid of ice, the drawdown slows. Carbon accumulates in the sky molecule by slow molecule. A thermostat stuck low, a pilot light that never goes out. No one day ends a white world. Dust darkens a margin. Meltwater pools drink light instead of throwing it back. Here and there, lanes of open water widen into seasons, seasons into habit. As the lid retreats, the sea meets air it hasn't touched in ages. Gases trade places in a hurry. Currents wake. Chemistry runs fast. That is when the bright cap forms, thick blankets of carbonate laid across many shelves, a sign of waters turning from starved to generous in a geological breath. Life answers in fits. Some lineages don't find their way back. Others seize the open rooms. Nutrients that slept at the bottom rise to light and bloom. Food webs stretch. It is tempting to draw a straight arrow from global ice to global creativity. The cautious telling keeps one step back. The thaw may have rearranged gradients and cleared shelves in ways that favoured novelty. The pages that follow in rock, more rooms inside bodies, new ways to move and eat, suggest the world had space to try. The freeze itself likely wasn't uniform. Ice pushed harder here than there. Some coasts kept seasonal breathing holes. Other shores wore a lid to the horizon. Mountains learned a new grammar of sharp and round. Even in the deepest cold, the planet kept a few small doors ajar. Stand again at that tropical shore as the thaw finds you. What was glass is wet. The first splash sounds too loud, as if the place had forgotten echo. Fresh soils appear where ice backs away. Rivers cut eager lines. Rain tastes like something the world remembers. The mirror smudges, then fades. Read together, the breath of rust and the long white turn disaster into something larger than endings. The atmosphere changed character. The seas turned over. Many lives were lost. And yet the stage that followed held more kinds of stories than the stage before. Upheaval erased, and then invited. Recovery is not quick. After the hardest collapses, diversity sometimes takes millions of years to rebuild, and many branches never return. What reads like a burst above a dark layer is paced by long quiet. Ranges left empty, guilds relearning their work with different players. The afterglow can be fertile, but it is never free. To say crisis can make room is not to bless the blow. It is to notice how slowly life spends that inheritance. So let's imagine stripping those events away. Picture a planet with no asteroid strikes, no sweeping glacial cycles, no sudden pulses of heat or flood. Life has time and stability. Populations settle into niches with no serious push. Patterns become fixed. Species refine themselves, but without pressure to adapt, their forms grow uniform, conservative. Complexity crawls more slowly. Would a smooth planet like that ever give rise to forests, wings, or consciousness? Or would it stall at simplicity, never prompted to climb the next step? Disaster works differently. A strike from the sky erases an incumbent species that dominated for millions of years. Space opens in ecosystems like abandoned houses ready for new tenants. Adaptable groups surge into those spaces, diversifying rapidly. New traits that once seemed marginal suddenly become decisive. A planet cleared of its old giants becomes a testing ground, favouring creatures that fit unexpected roles. Extinction resets the board, and in the reset, fresh forms appear that otherwise would have been locked out. Ice also sculpts. When ice sheets advance, sea levels drop, coastlines shrink and inland zones freeze. Entire habitats are pressed, forcing species southward or into refuge zones. Many cannot cope, but those that do carry traits of endurance into the next era. When the ice retreats, niches multiply. Populations diverge quickly to fill them, driving bursts of biodiversity. What seemed like blanketing ruin becomes the source of rapid branching, just as rivers carve valleys both destructive and fertile at once. Even mass die-offs, which sound absolute, often precede creative blooms. After collapse, ecosystems reorder, and surviving species take paths that smooth periods never offered. The shock is lethal, but the aftermath can be fertile. It is as if nature works in pulses, moments of calm accumulation, then ruptures, and then expansions. Life increases not in a straight line, but in surges scripted by turmoil. And yet, when we call disaster a sculptor, we must not mistake it for kindness. Countless creatures perished in each event, none spared by foresight or mercy. Suffering etched itself into every collapse. The paradox lies in the larger frame. Life overall becomes richer after losing most of what it had. The blow seems cruel. The outcome seems creative. Both truths sit side by side, inseparable. You can think of this through analogy. A forest fire strips a hillside bare. In the smoke and ruin, it seems purely destructive. But under the ash, seeds stir that only germinate after fire. New growth rises quickly in open light, feeding off the freed nutrients. The fire scars, but it also prepares, creating a succession of landscapes that would not exist without it. Scale that out to geological ages, and Earth's crises might be seen in the same way. They are not only endings, but openings. So, where does this leave the mystery of design? From one angle, upheaval seems like brute accident. What sense of guidance would arrange for impacts and extinctions? From another angle, upheaval can be folded into the larger balance. If evolution requires variation and space to adapt, then turbulence provides both. Disasters act like chisels striking stone. Rough blows shape figures finer cuts never could. Perhaps that is coincidence. Perhaps it is a deeper law that channels destruction back into growth. If you lean toward mainstream explanations, the answer rests in probability. Given long enough spans, random shocks were bound to occur. Those shocks filtered life, and we inherit the survivors. Complexity, in this reading, is less the product of sculpted design and more the side effect of endurance under stress. Organisms that happen to withstand disaster are the ones that diversified after each collapse. If you lean toward the design lens, you may see turbulence as woven into Earth's layered systems. The same way plate tectonics stabilizes climate through restless movement, cataclysms may stabilize evolution through forced novelty. What looks like pure violence could be the tool that prevents stagnation. Without it, life runs in small circles. With it, life steps upward, pressed by crisis into broader forms. Either way, the result across deep time is consistent. Biodiversity often spikes after collapse. In new spaces, fresh body plans, feeding strategies, and ecosystems emerge. Many of the forms we see today, fish with jaws, birds with wings, mammals in varied lines, expanded after crises that opened room for change. Catastrophe may not just end stories, it may write the next ones. Think again of that smooth planet with no shocks. It looks calm, but its story runs shallow. Contrast it with Earth, where the scars of impacts, ice ages and upheavals mark the crust in every layer. It is the very scars that tell us why life branched, expanded, and reached its present complexity. Smoothness might spare pain, but it also risks uniformity. Turbulence, painful though it is, leads to depth. So crisis, far from being only destructive, may be the hidden partner of creativity. It resets the ground, clears the stage, and forces experiments life would not attempt in steady calm. Each collapse is painful, yet each opens possibility. The paradox is sharp but inescapable. Disasters both erase and build. And now the larger riddle returns. If the systems of orbit, water, tectonics and shields all maintain balance, why should chaos appear at intervals to knock them down? Is it pure chance, or is the upheaval itself part of the pattern? A strange but necessary tool in a design that reads disorder as advancement. That is where we stand, looking at balance not only as quiet steadiness, but also as violent interruption folded into the same long arc. If upheaval can be part of balance, what does that say about a world that seems made for us? Why does it feel like Earth is so well suited to us? Because we are here to ask the question. If this place did not allow life, no one would be standing in a field looking up at the moon, or wondering about fine balance. This is the heart of what's called the anthropic principle. It states, quite plainly, that observers only ever arise in conditions that make observation possible. To us it feels striking, even uncanny, that air is breathable, water flows as liquid, and stars burn steadily. But in this framing, there's nothing odd about it. Conditions had to be like this, or we would not exist to reflect on them at all. The anthropic view feels straightforward, but only at first glance, because once you adopt it, every coincidence begins to read differently. Earth sits at just the right distance from the Sun, yes, but from the anthropic stance that's not remarkable. Any world too close to its star would not hold observers, so we would not appear there to take note. Ice giants, rocky planets off in frozen belts, barren asteroids, none have residents who can ask about meaning. It is not that Earth is perfect, it's that worlds not in balance have nobody to say otherwise. The filter acts invisibly. We only encounter life in conditions where it can persist, and silence drapes over every place it cannot. From Earth, the Moon and Sun share nearly the same apparent size, making total solar eclipses possible. It proves nothing about purpose. It does remind us how easily the mind reads meaning into tidy alignments. Wonder can stand without verdict. And yet tension arises here. If all this precision is simply the requirement for us to exist, does that mean the string of alignments, the moon anchoring our tilt, the magnetic field holding our air, the ocean's chemistry stabilizing the climate, carries no deeper significance? From one perspective, yes. Each system we've traced seemed unusually lucky until the anthropic filter explains it away. All those coincidences are only visible because we stand within one of the rare alignments that worked. From another perspective, however, there is room to wonder if luck alone accounts for it. That is where design-minded interpretations return, asking whether this long chain of accidents might instead be hinting at a deeper pattern or intent. Stand under a clear night and connect the bright points with your finger. A hunter appears, or a river, or a bird in flight. The stars didn't move to make that figure. You drew lines the sky didn't ask for. Still, once seen, the shape holds. The human gift, and hazard, is that we are very good at finding order. We see faces in bark, animals in clouds, stories in the scatter of lights. Some of this is survival, some of it is comfort, all of it is interpretation. Walk ashore after a storm. Two friends stop at the same jumble of driftwood. One sees chance, the tide's unplanned stack. The other sees a pattern, a long line of similar stems pointing southeast, a hint of where the wind carved hardest at dawn. Neither is wrong about the wood. They're choosing different lenses. The first lens protects against overreach. It says, "Do not promise more than the pieces can bear." The second protects against blindness. It says, "Do not miss a signal because it looks like noise." When we look at Earth's balances, those lenses sit in our hands. A magnetic field that shields, a code that forgives, water that refuses to sink as ice. Are these only the survivors of chance, revealed by the anthropic filter? Or do they also whisper arrangement when taken together? Your answer often starts before you begin. It starts with what you trust more. A world that converges by necessity, or a world in which order is permitted, maybe even invited by something deeper than accident? It helps to slow the question. Evidence is not a blare, it's a murmur. Ask 3 softer things. First, what else could draw the same picture? A sunflower's spirals point to efficient packing, rivers' branches point to easy paths in soft ground. The genetic code's resilience could arise because codes that weren't resilient simply didn't last. Each of those has a workaday explanation that doesn't require intention. Holding that possibility in view keeps hubris from hardening. The world is allowed to be sufficient unto itself. Second, where does a lens break? If you read design in every coincidence, you risk erasing the usefulness of the word. If everything is arranged, nothing is. If you read chance into every rhyme, you risk deafness when a tighter, testable mechanism is asking to be found. An honest lens includes its failure cases. What would look too clean? What would look too noisy? Name those edges before you decide what you're seeing. Third, what would move you? A good practice is to write down what could change your mind, more than once. If precise predictions from a pure chance account keep landing, perhaps keep that lens polished. If there's an underlying rule account keeps forecasting shapes before they're measured, perhaps adjust toward the rule. Staying movable is a kind of humility that science and faith, each in its own way, both claim to admire. We also bring priors we rarely examine. A life spent with instruments teaches you that patience wins. Many features you once called uncanny turn out, under measurement, to be the normal behaviour of matter under constraint. A life spent in attention to meaning teaches you that surprise is a clue. Many features you once called brute fact begin to feel like invitations to look closer. These are not enemies, they are temperaments. Consider a smaller scene. A farmer reads her field at sunrise. The soil is darker in a narrow band. The wind last night shifted and laid dew where it usually does not. She doesn't call it fate or accident. She calls it weather and makes a choice. Plant here this afternoon, wait there until tomorrow. Interpretation at its best is not a verdict. It is a guide for the next step. The same is true at the larger scale. You can say, with the anthropic lens, that we live here because only places like this make observers possible. You can say, with the design-leaning lens, that a chain of alignments feels like more than survival bias. Both statements are attempts to navigate, not only to name. The important test is not which one flatters your temperament, but which one helps you keep looking without closing your eyes to what does not fit. There is also the matter of selection. Survivorship hides the outtakes. We do not hear from planets that froze early, from codes that collapsed, from worlds where ice sank. Silence is not proof that they were few. It is the expected quiet from places that never learn to speak. The filter is real. So is the pull, in creatures like us, to treat the one speaking case as central. Guard both truths at once. We are biased toward noticing what worked, and yet what worked here is astonishing. A helpful posture is to treat patterns as promises to inquire, not as conclusions. The way a dune fields itself into even ridges, the way a forest organises its breath into afternoon rain, the way a code catches its own slips. All of these are reasons to ask deeper questions. Sometimes the answer is constraint does this. Sometimes it's chance permitted this. Sometimes it's many small local rules compose into something that looks like care. We need not rush the last line, and yet it is fair to admit wonder. A person can measure dust in ice and still stand quiet at the thought that tiny bubbles carry old winters. A person can trace every step of protein folding and still find joy in the fact that a cell tutors its own mistakes without an overseer. Wonder is not a trump card. It's a fuel. It keeps us from treating the world as a solved puzzle when it is still a living place. If we must choose a sentence to carry forward, choose a generous one. Hold both stories lightly while you keep your hands on the evidence. Read the balances as necessity where you can show it. Allow the possibility of arrangement where the stack of coincidences grows taller than your comfort, but let that possibility make you more curious, not more certain. There is a practical edge to this. Whether Earth is a narrow accident or a narrow arrangement, it is narrow. The window is not large. The same clocks that paced ice ages will pace other turns. The same tectonics that steadied air will one day slow. The same sun that warmed our seas will keep changing its tune. We are here now. Interpretation should lead to care. Return to the night sky. The constellation you drew is not wrong because another person draws different lines. Both of you are organising light to make sense of where you stand. Tomorrow the same stars will rise, indifferent to your stories, but the stories you carry back down the hill can make you kinder to a fragile place. They can make you patient with people who see a different figure in the same scatter. They can keep you looking up, and if we are to keep looking, the next step is to look ahead. A world this finely balanced cannot last unchanged. Some doors will close, others will crack open. The question is not whether the pattern keeps us comfortable forever. It is whether we can learn to live skillfully inside a window that was never promised to be wide. One angle to resolve the tension imagines a universe larger than our senses. Suppose that beyond our visible frame are countless other universes, some with different laws of physics, others with small shifts in constants. The strength of gravity, the masses of particles, the behaviour of light. If even one of those constants shifted here, even by a fraction, stars might never form, or atoms may never hold together. If there are countless such universes, then the fact that one, ours, permits life becomes less surprising. It would be inevitable that observers would appear only in the handful of universes where conditions align, and those beings would naturally feel puzzled at their fortune. The multiverse then converts improbability into statistical inevitability. Still, not all thinkers find this satisfying. A group sometimes called the rare Earth perspective argues that the number of alignments required here feels too steep for chance. From their view, we do not just need the right orbit around a calm star. We need also the moon's strange origin to stabilise seasons, plate tectonics to recycle gases, a magnetic field to preserve atmosphere, water tuned with peculiar physics, and a code of life flexible yet stable. Each feature on its own might be explained away, but together the stacking begins to feel less like inevitability and more like a razor's edge. They suspect Earth may be far more unusual than many expect. A long sequence of low probability events collided at once. So let's work a thought experiment. Shift one parameter by even a small degree. Remove the moon, and Earth's tilt wobbles chaotically, producing climates too unstable for long-term ecosystems. Let the magnetic field fail, and radiation strips the atmosphere grain by grain. Let water behave like a typical liquid, and ice sinks, turning seas into solid prisons. Life as we know it would likely collapse at each change. The margins are that fine, and if billions of planets across the galaxy exist, some without moons, some without magnetic cores, some orbiting violent stars, then the vast majority would stand barren. The filter explains this again. None of those places will ever speak. Only planets like Earth, with its long sequence of conditions, will ever carry voices considering the problem. Now imagine walking through a gallery of worlds, each one displayed under glass. Thousands with thin atmospheres unbreathable. Thousands scorched under suns that flare unpredictably. Thousands more buried under endless ice. Almost none have conditions aligned for observers. Then there is Earth's frame, where air flows warm and water remains fluid. It is the one case in a long display where you can stand inside and comment aloud. The mystery then is sharpened. Is Earth unique only in being the voice among silence? Or is it also unique because some guiding factor led it to hold such an unlikely chain together? This is the puzzle of the anthropic filter. It silences every uninhabitable system, leaving us only the samples in which life endures. That naturally biases our perspective, We speak as though the odds are small and Earth rare, when in reality we cannot view the failed worlds to compare. They exist, but they do not tell their story. Only places compatible with awareness can do that. Which interpretation you choose depends on comfort with chance versus order. To one ear, the filter reduces mystery, to another it deepens it. There is also a quieter riddle, sometimes called a great filter, though we need no label for it. If many planets begin, how many make it far enough for questions? Somewhere between first spark and self-aware speech, most journeys may stall by ice, by impact, by drift into sterility. Perhaps part of the filter is not only behind us but ahead. That thought does not darken the story. It sharpens the care we owe the part we can still choose. Either way, the framing changes how we see ourselves. If the anthropic argument holds, we exist not because Earth was singled out for perfection, but because only within such narrow ranges can beings like us appear at all. If the design lens holds, then each of the balances we've described adds up to something more than survival chance. It becomes evidence not only that we live here, but that perhaps the Earth was, in some sense, arranged. The difference is subtle but important. Do we treat coincidence as explanation, or coincidence as signal? Layer by layer, these tensions build. Probability tells us much of what seems uncanny is only the silent filter of survivorship. Design speculation points instead to direction. Both agree on the effect. Earth is rare in the ways that matter for us. We breathe easily because conditions allow it. We wonder about balance because balance holds. Silence speaks from worlds without either. And so the payoff is simple. The reason Earth feels perfect to us may not be because it was destined, but because impossible places cannot ask the question. We live inside the narrow filter of survivable space, and our awareness is its byproduct. That fact can feel both grounding and uncanny at once. Now, let's pull back from these wide speculations and multiverse imaginings. The cosmic scale shapes our sense of improbability, yes, but we also live here now, on a fragile planet with dirt underfoot, weather gathering overhead, and seas circling the continents. The lens you choose, chance, design, or filter, shapes not just what you conclude, but how you act on Earth as it exists today. Because this planet, layered with such balances, asks us for more than speculation. It asks for response. Step outside at dawn. The same balances we've traced are at work. Dew lifting from soil, a breeze written by last night's cooling, a line of cloud building over the dark strip of trees. None of it asks for your verdict. It asks for your care. However you read the story, the next good step is small and local. Keep the windbreak, shade the water, waste less fire. We've imagined shattered scenarios, Earth without its moon, without its shield, without its balancing codes. Those thought experiments showed us how fragile the planet's arrangement really is when you strip away one part. Now let's return to the living Earth right here under our feet. Soil layered by seasons, air carrying water across continents, a magnetic shield humming above, DNA woven into every cell. All of it stacked in a way so thin that a slight change sends the whole system skewing out of line. You might feel this as a thread weaving through the different scales, orbit, chemistry, tides, tectonics, even the code inside a microbe. None of those on their own feel destined. They look like improbable winds strung one after another, and yet here we are, standing in their combined shelter. It raises a question that does not quite leave us alone. Does this stack of fine balances mean something beyond survival? Or is survival itself the only measure that matters? Practical science leans toward the latter. By that account, Earth looks rare because we are here to count its traits. That is enough of an answer. It says orbital distance, magnetic layers, chemical quirks. Each is explained by physics and chance, and we only find them interesting because they happen to support observers. This is the tone of the anthropic principle, the filter that silences every unlucky world. The explanation works. It carries weight. Yet it does not satisfy everyone. Because there is another way to read it. Suppose instead of chalking everything up to survivorship, you allow yourself to hold the idea of design, not as a verdict, but as a lens. In this way of seeing, the stack of balances is not just coincidence. It is something purposeful, not necessarily planned by a person, but purposeful in how it arranges pieces into a functioning whole. You do not have to declare evidence of intent to use this lens. You use it as a thought tool, something like a magnifying glass, to see patterns that ordinary explanation might skip. Think about how we read art. A painting can be viewed as pigments distributed across a fabric, nothing mysterious in the act of chemistry. That is the pragmatic stance. But step across the room, change your glance, and the image pulls together. Form, light, balance, composition. Neither view cancels the other. One explains, the other interprets. Reading Earth's balances as design can be like this. It does not refute physical law, but treats the outcome as a kind of arrangement worth respecting. I want to hold the tension clearly. Scientific practice depends on testing, on limiting itself to mechanisms we can track. By that standard, the anthropic principle and the multiverse frame serve as clean explanations. We see order here because only ordered places produce observers. Interpretive science, in contrast, takes license to ask, could this improbability point to deeper laws, or even a kind of directionality stitched into the cosmos? It does not claim proof. It does not claim revelation. It entertains pattern as meaningful, even when mechanism cannot yet describe it. So what do we gain by keeping both views nearby? Practical science gives us tools, models of climate, maps of tectonic risks, chemical accounts of oceans. These matter if you want to manage resources, respond to disasters, or build technology. But the design lens, even unprovable, shapes perception. It makes you notice fragility more sharply. It reminds you that balance is not casual. In that sense, it may change conduct. If you see Earth as chance, you might treat it as expendable. If you see Earth as designed, even figuratively, you're invited to treat it as gift. And yet, it is not really about picking one camp or the other. The central point is that you, as an observer, have a choice in how to frame these alignments. There is no penalty for reading them pragmatically. There is no penalty for seeing them as signals of directionality. The choice is less about origins. No clean answer can be reached there, and more about action. How does our view of Earth transform how we live on it? Call it stewardship, humility, or wonder. Each depends less on what the universe is and more on how we see it. If balance looks like accident, our care may be casual. If balance looks like arrangement, our care grows sharper. The science holds steady in either case. The tilt must remain anchored. The air must resist erosion. The seas must buffer. But the story we tell ourselves about those systems can change our attitude. To read them as designed is to treat them as deliberate supports, things one does not rashly endanger. That perception itself can guide behaviour, whether or not the perception is literally true. Think again of the analogy of a book. You can treat it as sheets of pressed fibre with ink patterns across them. That is fact. But you can also treat it as text, with grammar, arc, and suggestion. Both are true, but only the second guides you to savour, to reread, to let the story shape your thought. Earth's balances can be read that way too. The raw stacking of processes can be treated as chemical inevitability. Or, without discarding that, you can let yourself read it as layered text, coherent in its arrangement. That act of reading affects how you inhabit it, and this is the quiet payoff. The choice is not about proving design or disproving chance. It is about shifting perception, which shapes action. You don't change tectonic plates by seeing them differently, but you might change your treatment of forests, oceans, or technologies if you carry the sense of a planet that feels purposeful. The reading becomes not a hidden fact, but a living influence. We began this journey imagining Earth undone. each balance missing, life faltering. We arrive now looking at Earth intact, fragile, and improbably steady. The temptation is to capture it with a verdict, accident or plan. But maybe the more useful stance is to see those categories as tools. Each helps us notice something different. Each adds dimension to our awareness. And Earth, as it turns out, deserves more awareness, not less. So where does that leave us? Standing on a planet whose fragility is layered across orbit, shield, water, tectonics, DNA. We can say it is rare. We can say it is arranged. Both statements change how the story lands, and that finally leads toward the last question. What does Earth ask of us once we see it in this light? Not an abstraction, but right here, as stewards, participants, and temporary guests on a world that, whether by chance or by arrangement, holds its balances just long enough for us to notice. Stand still for a moment and think of Earth not as background scenery, but as a structure held together by balances stacked one on another. Orbit, water, air, and code all combine so precisely that the planet feels like more than a stage. It feels like an invitation. Whether you frame it as coincidence or as design, the message lands the same. This world asks us to treat it with care. Stewardship follows from humility, and humility grows from wonder. Stay with the question, and see what new responsibility begins to grow the longer you hold it.